Welcome to manage and optimize your Azure Virtual Desktop using ControlUp. So a little bit about ControlUp and what we do. We have what we call the Dex Management Platform. So this is your digital employee experience. And in the past, what you've done is you've got the employee and the technology, and they're very separate pieces in your organization, and the employee will interact with all of these resources and will have technology to monitor them and track them and so on and so forth, but nothing has really put them all together until now. So with ControlUp, what we are doing is we are redefining what Dex looks like. We are taking the employee's experience, their digital experience, and we're putting it in the center. And with ControlUp, we are monitoring all of these different pieces of your organization, whether it be physical endpoints and VDI, unified communication tools like Teams, or web apps that you have in your environment. So using ControlUp, we can actually track all of that, and we can bring it together holistically within the ControlUp Dex Management Platform, giving you that end-to-end view of your employee experience in your organization. But enough about the high-level stuff. Let's get into the demos. So first thing I want to show you is how we can use ControlUp automation to improve the Azure Virtual Desktop performance. Okay, so I've logged into Solve, and this is the first screen you see. So this is the dashboard view that we have within Solve. So you can see here by default, we come with 3 different dashboards showing you all metrics, user experience metrics, or resources metrics within your environment. You can go and you can share dashboards. You can set them as default in your organization, or you can create your own custom dashboards. I've actually created one here called the Azure Cost Dashboard. And if I go ahead and select that, I get some cost metrics related to the Azure resources in my environment. So we can see the overall cost, WVD pooled, 0 and 1. These are costs of individual virtual machines. I've got my Azure forecast versus actual cost graph, and I can see the Azure resource group costs. So I'm going to switch to the discovery view now. And so this is showing all the resources that we're monitoring within the environment. I'm going to focus on user sessions because I've got some AVD user sessions that I would like to show. And so first thing I'm going to do is I'm just going to adjust it to be a custom AVD metric column preset that I've defined. So you can see at the top here, this is my session T-tie. I'm actually just going to filter just to make it a little cleaner. And boom, we've now filtered, 60 sessions in just a second or so. And we can do that with thousands of sessions, no problems. So I've got my top session here, T-tie, and I'm connected into my machine WVD pooled 1. This is a Windows 10 Enterprise for Virtual Desktop machine. We can see the stats that we're pulling from here. So my stress level is critical. And if I want to know why, I just need to scroll to the right, and I will see all the various metrics be color coded. So red is bad, which is contributing to the stress level there. Stats like CPU, memory, the IO, I'm just going to scroll to the right and we can see other stats. These columns are adjustable. We can actually drag them around so that way you can see more. You can rearrange them. You can move them left or right, remove them, so on and so forth. So, we've got some interesting stuff like we can see the bandwidth that's being consumed by this session is around 53 megabytes. That's quite a bit. You can see it's an RDP-SXS session, so that is showing you that we're connected in through the Azure Virtual Desktop stack. And we got some metrics that are purely for Azure Virtual Desktop themselves. So we track things like the average encoding time for each frame that you have within your organization that your session is producing, and the frames per second. So what your user is actually experiencing in terms of the refresh that their display is getting updated at. So 18 frames a second is pretty good. If you're watching a video and it happened to be 1 or 2 frames a second, then you would know it'd be bad. We have these frames skipped columns as well. These ones will actually track whether frames that were dropped because of a network problem, a network utilization problem, or a server load problem. So if the server's overloaded, it'll tell you that frames were skipped because the server didn't have enough CPU capacity to encode them. And then you also have on the client side. So if the client reports back that it was unable to receive the frames because it lacked resources or something, you'll get that notification as well. So what I'm going to do is I'm going to show an automation that can optimize your environment. So we can see a couple things here. We can see the state of the session. So active means the screen is being actively remoted. We can see the memory working set is 1.75 gigabytes, so that's quite a lot of memory. And what I'm going to do is I'm going to simulate a user logging off this machine, or disconnecting from it, I should say. So say at the end of the day they walked away from their terminal, and then the timer goes in, idles out and logs them off. So we can see here I executed an action all from within the Solve UI, by the way, to disconnect this user. So we're simulating this task. So the user is now in a disconnected state. We can see the CPU utilization drops pretty significantly. So we have some script actions that actually go and reduce the CPU base priority of all the processes within that session. So it drops them all to a preset you define, by default is below normal. And here we'll see the memory working set actually get trimmed as well, freeing up memory for any other user on your Windows 10 multi-session machine. And so this is super cool because obviously full desktop sessions consume quite a bit of resources, and when users are not consuming those resources because they're in a disconnected state or some such, we can automatically free those resources for other users on the box. So this way they have more memory, they have more CPU cycles, they can be more productive. And boom, you can see it went from, what was it, 1.6 gigabytes of memory down to 142 megs. So we've freed up over 1.5 gigs of memory for other users on this machine to be more productive. And the reverse is also true. If the user, say, were to come back, they went for lunch, they went into a disconnected state, they came back, well, obviously we don't want to keep them in this throttled state. So we will also do the reverse. We will pick up that the session is in a disconnected state, and we will flip it back when it detects that the screen is being remoted again. So when the state turns back to active, ControlUp will automatically adjust the process party back to what it was previously, and we just let Windows Memory Manager start paging in any purged memory that it had previously. So you can see it's now gone up to 800 some odd megabytes. All right, let's go over the next thing that I think is critically important, and that's making sure your Azure Virtual Desktop resources are available. So that's either desktops or published applications. And for ControlUp, we have this synthetic monitoring tool we call ScoutBees. And a new feature we've added is the ability to actually test your Azure Virtual Desktop resources to make sure that they're available. So I've got one set up here that is testing a published desktop for us. We've called the test the Azure Virtual Desktop Scout. This is what it looks like once you've set up a test. So you can see things like time to session ready. So this is when you first try to connect to the resource to when the desktop says it's available. And then average load time here breaks out that time to session ready in more granular phases. You can see we can define alerts for these tests. So if your desktop isn't available, we can specify a condition. My favorite is probably this image anomaly score that I'll go over in a little bit. And we can define conditions for anything you see here. So even the average load time, the authentication, enumeration, connecting, initialization, ready phase, we can define any of those. In the baseline image, so going back to the alert policy, what we can do is we can alert on how close it is to a reference image that you specify for what the scout saw. So we've got our reference image here showing a desktop. We can see we've got 5 of the last tests showing what their scores are. So we can see they're all, in the 95 plus, except for this one that's rated at 66, and you can see the difference. So it's a pretty massive difference. So now that we know what that is, we can go back to alert policy and we can say, okay, we know anything above 95% seems to be pretty successful, so let's define that as our criteria. So we will I'll actually do 90 just to give it a little bit more buffer. We can add different notification methods. So whether that is an email alert, which is, I guess, the bog standard one, but we also have integrations into things like ServiceNow or Teams that you can specify, and you can get alerted and notified that way. So if you do connect into ServiceNow, we do open and close tickets automatically when we detect availability issues. But I'm going to select Teams here because I like getting notified in Teams. So I want to show you what these test results look like. So I'm going to choose the last 2 days here, and I'm going to select my failure so you can see what a failure result looks like. So here we can see we failed to authenticate on this particular test for some reason, maybe an Azure AD hiccup or something like that. And here's what a successful test looks like. So you can see here we track again all the individual phases, and we get this nice little graph showing how long each one took. We can see what the test saw when it connected in, so it'll take a screenshot of that. And this is what you get when we are testing Azure Virtual Desktop availability. So pretty cool stuff here. Okay, so let's move to the last demonstration that I'm going to give. You can also check out our other sessions for other demonstrations as well. So this one we're going to show how we can save more on AVD costs using ControlUp automation. So I'm going to switch over to my dashboard view here, because you can actually see I've got my two virtual machines here and it shows their costs. So WVD pooled 0 is one that's using ControlUp automation to reduce the costs of our Azure Virtual Desktop machines. And WVD pooled 1 cost is one that's running 24/7. So you can see pretty significant cost savings can be had versus running 24/7 for your virtual machines. And so how do we do this? So I'm going to switch to the ControlUp management console, and here you can see we have this triggers feature, and here we've got these 5 triggers that contribute to our cost savings. So the first one that I'm going to select is a schedule trigger that will stop any Azure Virtual Desktop machine who has 0 sessions. It will do this after 8:05 p.m. It's going to run it every day at 8:05, and it checks for 2 criteria. So it looks for the power state to be running and no user sessions to exist. For the purposes of my demonstration here, I've added another criteria for the virtual machine name. So I've added the Azure Virtual Desktop machines within ControlUp here, and I've got a schedule that says that this trigger will only be active from 8 p.m. on, and it will execute the action stop and deallocate the machine. I've got the second trigger here that is a state-based trigger. So what that means is it will look for state changes. And so the state changes it's looking for is the Azure power state is running, user sessions has transitioned to 0, and it's operating every 5 minutes. And same thing, we got our scope selected. We're going to choose the schedule to be executing for after hours, 8 p.m. to 5 a.m. And again, this one is only going to monitor that users are transitioned, or that machines have transitioned into no user sessions and are running after hours, 8 p.m. to 5 a.m. So this next trigger is again a state-based trigger. So this one will actually check to see if the machine is in a stopped and deallocated state, and is the disk set to SSD. If both these conditions are true, and this occurs after hours, 8 p.m. to 5 a.m., we're going to execute the action, change the machine disk type to standard LRS. So this changes it to the cheapest disk type that we have. And then obviously we want to do the reverse. So in the morning, at a specific time, we're going to want to change the disk back to SSD. So here you can see we're using a schedule trigger, and it looks like, it's running for over a year every 5 minutes, which is true, but we have our conditions here that it needs to be stopped and deallocated, and the disk needs to be standard. But here you can see for the schedule, this defines when that trigger is active. So it's going to run every 5 minutes, but only at 6 a.m. And so here's what that trigger looks like, or that schedule looks like. So the blue is when it's active, white is when it is not. So to change your active, you select time period, and you just hit one of those 2 radio buttons and it'll adjust it. So I'm going to set this to be operating at 6 a.m. So at 6 a.m. every day, it will check to see if there's a standard SSD, or sorry, just standard hard disk, and if it's powered off, then it will adjust the disk. And here is where we turn it on. So because we don't want to turn on the machines when the disk is not an SSD, we're using the same scheduled trigger trick. But this time we're looking, is the machine powered off, and is it an SSD? And if it is, now we're going to start it. So this way we ensure that our machines are always being powered on when they have an SSD disk type, and they're not getting powered on prematurely with a hard disk. With that, you can try ControlUp for free by downloading it off our website, and be sure to check out our other sessions we have here at Ignite.